Hello everyone. I am Professor Smita Chandra Tolani, Assistant Professor Applied Physics, St. Vincent Pallotti College of Engineering and Technology, Nagpur. Learners, today we are going to start the unit of crystallography, and in this unit we are going to study what is the crystal structure of a particular element. Basically, what are crystals, why we study crystals, what is the atomic arrangement of crystals, what is the advantage of studying crystallography, and therefore this unit is also called as atomic structure, or you can say structure of solids. So basically, amongst all the solids, we are going to focus on crystals and study the experimental science of determining the arrangement of atoms in a solid, and scientific study of crystals is what we are interested in this particular unit. Let's begin. First of all, what do you mean by crystals? So let's see a classification of what do you mean by crystals. Now, solids are basically of two types, or rather I can say broadly classified into three types. The first type is a single crystal. The second type is a polycrystalline solids, which is again crystalline in nature. And the third type of solids that we have are called as amorphous solids. Now, what is the difference between these three types of solids? So basically, amorphous solids are the solids which have no particular atomic structure. So we know that any solid is nothing but it is collection of large number of atoms. As Avogadro number says that in 1 cubic meter of a solid there are 10 to the power 23 atoms. That is our Avogadro's number. So it says that basically a solid can be defined as a particular collection of atoms, in which the atoms are arranged in a particular way, or a particular structure or particular order. Okay, so order is nothing but the arrangement of atoms which is repeated over a certain distance. So basically I am going to classify the solids into these three types based on their atomic arrangements. So here we are defining a solid as nothing but the collection of atoms. Okay, here atoms are distributed in a certain way, in a certain manner, or in a particular order where a particular atomic arrangement is repeated over certain distances. So when I talk about an amorphous solid is nothing but a solid in which there is no order of atoms. So atoms are not arranged in a particular arrangement or in a particular manner, or there is no similar arrangement of atoms repeated over long distance in an amorphous solids. Or we can say that an amorphous solid is the one in which there is a random arrangement of atoms. The examples of amorphous solids are glass, rubber, polymers, wood, etc. As you can see in this diagram, here the atoms are haphazardly or randomly arranged. There is no particular order or arrangement which is repeated over long distances in any of the directions in an amorphous solids. So it does not have any periodic or regular arrangement of atoms, and atoms are randomly arranged in an amorphous solids. And when we talk about a crystal or a crystalline solid is a one in which there is always a regular and periodic arrangement of atoms. Now, what do you mean by regular and periodic arrangement of atoms? So basically all the crystals have a particular order, or what we call as a long range order, where the atoms are arranged in a particular manner. Similar arrangement will be repeated over long distances in different directions. So a crystalline solid is the one in which there is a regular, that means the same pattern of the atoms, regular and periodic arrangement. Periodic means the same arrangement will be followed, or it will be repeated over distances. So they have a distinctive shape, they have smooth faces, straight edges, and they basically have periodic and long range order of the atoms. The examples of crystalline solids are diamond, quartz, rock salt, alum. And again, crystalline solids are divided into two types: single crystals and polycrystalline solids. Now, what are single crystals? Since they are crystalline solids, Therefore, they have regular and periodic arrangement of atoms, where there is a long range order. The same arrangement of atoms is repeated over long distances to form the entire structure. They have distinctive shapes, smooth faces and straight edges. That means by looking at the structure you can determine that there is a particular structure or shape for quartz, there is a particular structure or shape for alum, the particular structure for diamond. So they follow a distinctive shape for each type of crystal. They have smooth faces, straight edges. When they break, they follow a particular alignment. That means they break with certain alignment and follow law of constancy of angles. That means there will be angles which will be between their edges would be constant. Possess both short range and long range order. They are highly anisotropic. Now what do you mean by anisotropic crystals? Anisotropic crystals are those crystals in which the properties of the crystal or properties of the solid, they are direction dependent. That means anisotropic crystals would be those crystals in which the physical properties like the optical, physical properties, metallic properties, magnetic properties, all these properties change with direction. So the physical properties, metallic properties, optical properties, all the properties of the crystal would be different in different directions. Those solids are called as anisotropic. The examples of single crystals are quartz, rock salt, alum, diamond. All have distinct shapes, sharp faces, smooth faces, sharp edges, and they follow law of constancy of angles, possess both short range and long range order, and their properties change with direction. The example of, as you can see, quartz, rock salt, these are single crystals, and here we have shown that these have regular periodic arrangement of atoms, and you can see that the long range order is followed here. Now the second type of solids or the crystalline solids are polycrystalline materials. The examples are metals, and these basically are nothing but the collection of single crystals of irregular shape. Basically this does not contain one single crystal but has several single crystals aligned in different directions, separated by definite boundary walls. So each single crystal of an irregular shape of the size 10 to the power 3 or 10 to the power 4 Armstrong is called as a grain. So a grain is nothing but a single crystal like this of regular arrangement of atoms, distinctive shapes, smooth faces, straight edges, and such a single crystal of irregular shape of the size 10 to the power 3 to 10 to the power 4 Armstrong is called as a grain. So many single crystals of irregular shapes of this size coming together is called as a collection of grains. So these single crystals are separated by well-defined boundaries, and they are oriented all in different directions, and therefore the collection of such fine grains separated by well-defined boundaries oriented in different directions are termed as polycrystalline solids. As you can see in this diagram, here the arrangement of atoms is aligned in this direction. So this cluster forms a single crystal of irregular shape. Again we have another cluster of atoms in which the arrangement follows this particular direction. So all the atoms here are arranged in this particular direction. This follows another single crystal of irregular shape. This is a third oriented single crystal, fourth, fifth, like this. It is a collection of large number of single crystal of irregular shapes of size 10 to the power 3 to 10 to the power 4 Armstrong, and they are all oriented in different directions. They are all separated by definite boundary walls, and each of the single crystal is termed as a grain. So here the collection of all these grains which are separated by well-defined boundaries oriented in different directions are termed as polycrystalline materials. Here each grain is shown and is separated. So example is metals, and they are isotropic in nature. Now what do you mean by isotropic solids? These are the solids in which the physical properties like refractive indices or optical properties, then magnetic properties, mechanical properties, all the properties of the solid remain same in all the directions. So the direction will not change its properties. Because of the atomic arrangement, the properties are same in all the directions. So basically in this video we learned that we are going to study crystallography in this unit. Now why do we want to study the crystallography? Because it is very important to understand the structure of the solid or structure of a crystal, because the structure defines the properties of any solid. Now once you understand the structure and the atomic arrangement of any solid, you understand the properties of that particular solid, and hence by knowing the properties you can apply those properties to use that crystal for various applications. We are going to study applied physics, therefore we are going to use those particular crystals or the solids for various applications. So once we know the properties of a particular solid, we can use that solid for our desired application and use. We can even modify the properties once the properties are known to us for suiting the purpose of our application. But for knowing the properties of any solid, it is very important to know its atomic arrangement, and therefore we are very much interested in knowing the atomic arrangement in a particular solid to understand its structure and hence its properties. And the basic aim would be to use all these informations and the knowledge that we gain to use the particular solid for various applications, and use it and maybe modify its properties to suit our application. Therefore, in this particular unit, we are basically going to focus on one type of solid, which is a crystalline solid. And hence, here to summarize this video, what we have learned in this video is that a particular solid is nothing but collection of atoms arranged in a particular manner, which we call as an order, which is repeated in different directions over a periodic time. Now, we learned a broad classification of the solids into amorphous solids, crystalline solids. Again, crystalline solids are classified as single crystals, and polycrystalline solids. Out of these, we are going to basically focus on crystalline solids, that is single crystal and polycrystalline solids, but we should know what is an amorphous solid. So again, a crystalline solid is the one in which there is a regular and periodic arrangement of atoms. They have long range order. Okay. The examples of crystalline solids are metals, rock salt, alum, diamond, quartz, etc. Calcite can also be an example of crystalline solids. Amorphous solids, on the other hand, are the solids in which we are not interested in right now, but we must know what is an amorphous solid. It is nothing but a solid in which there is no regular arrangement of atoms. The atoms are haphazardly or randomly arranged. They do not follow any particular order, and they have short range order of atomic arrangement. The example of amorphous solid is glass, rubber, polymers, wood, etc. This is an amorphous solid where there is a random arrangement of atoms, and a crystalline solid where there is a regular, periodic and long range order of atoms, where the same arrangement is repeated over long distances in all the directions to create your solid. So again, crystalline solids are defined or classified into two types. Single crystals, which have regular periodic arrangement, can have smooth faces, sharp edges, straight edges, distinctive shape for different materials. They have both long and short range, and the examples are quartz, alum, diamond, rock salt, calcite. They all follow the laws of constancy of angles, and you can see they are anisotropic. That means their physical properties change in different directions. Polycrystalline solids, the example being metals, are nothing but the collection of such single crystals of irregular shapes of the size 10 to the power 3 to 10 to the power 4 angstroms. They are all arranged in different directions, and they are separated by definite boundary walls. Each single crystal of irregular shape of size 10 to the power 3 to 10 to the power 4 Armstrong is called as a grain. Therefore, a polycrystalline material is collection of grains separated by well-defined boundary walls, oriented in different directions, and they are isotropic in nature. Isotropic means their properties are same in all the directions. So, we summarize that crystalline structures are the structures which have regular and periodic arrangement of atoms, and in this unit, in the coming videos, in the following videos, we are going to focus on the structure of these crystalline solids to understand their properties and their applications. Thank you very much.